So let's continue our installations of SUSE. So this time, now that we have our server and desktop systems running, let's implement another server. This one we'll call Linux CBT SUSE 2, but as you know, when you install it, uses an arbitrary or random name, and it's changed after using YAS or by impacting the appropriate config files. Nonetheless, there's so many different ways with which you can install SUSE Linux. It's rather flexible. So let's look at this other method, and that's going to be, let's say, SUSE server. This time it's going to be SSH-based installation, which obviously means network. So network base installed from remote client, and basically requires limited effort on the server side. So for us, that's going to be, of course, via VMware ESXi. So you do very little on one side and handle the rest from the other side. And that saves you from having to, let's say, be physically somewhere. Or perhaps you could relay instructions to junior staff to bring the system to a particular state, to have you continue it from another state. So how do we get this going? Well, install via SSH. So of course we need to provision an instance on the host server, which of course is ESXi. And we reference the ISO image, so reference ISO boot image. And then we make or indicate at the install screen that we'd like to use SSH or any other option for that matter. So let's see what's entailed. We'll pop back over. So we have Linux CBT SUSE 1. We want another instance. New virtual machine. Custom. Let's call this Linux CBT SUSE 2. Default data store. And this is going to be SUSE 11. We'll just use the 11 profile because this version of ESXi is unaware of 12. But that's fine. The profile, that's no problem. The profile is pretty much the same. Let's put this on the base network. Go with some of these defaults. No existing disks. Let's just keep this consistent 20 gigs like with the other one. And modify it to use the ISO image momentarily. So, new CD-ROM. ISO store, data store 1 for us. In the OS ISO images directory, our repository SLES12, and the smaller of the two. And if you have even smaller, boot only, that will work as well, so long as you have a network means with which to access the installation content. So that looks good. So this should boot to that image once we fire it up. So let's go ahead and do that. So SUSE 1 will sit on top of SUSE 2. We'll power this up, navigate to the console, and tell it to kick everything back to SSH. So there's the installer, straightforward. But before we let it install, we want to send some options in. So use SSH equals 1. I will set an SSH password equal to install SUSE 12. And you may optionally specify an IP or just read the IP that's derived from DHCP and reference it from your client. And everything else, once we get beyond that part, will be handled up until the end of installation or the installation from the client. So let's go ahead and tell it to install. Use SSH password. This will configure the NIC and indicate to us the address to which to connect to. And the password that we've indicated is the password that we will use to connect. That's the install SUSE 12 from the client. So there it's setting up the Ethernet 0 interface, auto-configuring it from the network, and it'll tell us the settings momentarily. It'll also tell us how to connect. So let's see what it's doing. Let's take a look. So it's derived the address 7527, the next logical address, 7527. Pay attention to that. And here are the instructions to log in using SSH uppercase X, which redirects X Windows communications from the server to the client, logging in as root using the password we've just indicated, and then subsequently running yas.ssh. So that's all that's needed. So a junior administrator could say perform this portion, and then from your system, wherever you happen to be, you connect from the client. So provision instance, boot, and obtain connection details, largely the IP and instructions, which is basically yas.ssh. So we know we're connecting to 27, so let's make this C, connect from client. And C1 is going to be that we SSH using the uppercase X option as root to that IP address 7527, which will serve as a temporary address. And then we'll follow that up with the yas.ssh, which will continue the installation. So let's take this and pop it here in our shell. That should connect us momentarily, and we should get some sort of dump. Let's double check our password. Install SUSE12, and there it says run yas.ssh to continue the installation. So yas.ssh is the script that'll kick things off back on our local screen. If there are any problems writing to your local screen, it's because the X permissions doesn't permit the user with whom you've connected to the remote system to write back to the local system. But here you can see it's working. And the subsequent install will look at the GUI, but this one's curses based, which is fine. No problems whatsoever. Let's agree to the license and move forward. So next. And we'll skip this portion as we've done before. We can influence the network configuration. Let's edit that interface. So of course it's DHCP. We want a statically assigned address of say 141, 75, 141, the next address. That looks good. This is going to be SUSE2.linuxcbt.internal. No additional addresses for now. So the static address should be assigned once we commit these changes. Let's navigate to next. And this is the registration, which we've done before. We'll just skip that. No additional products for now. And notice we still have connectivity, obviously, using the 27 address. So that is obvious, or it should be obvious, that the new address 141 has not been written. There's a proposed file system, which is a default btrfs, default root file system with default subvolumes that map to the common directory, such as temp, opt, home, serve, etc. And we're not ready to make any changes to those settings, so let's pick GMT. Hardware clock set to UTC. That's the case with our VMware BIOS configuration. We specify a user. It derives a lowercase name for the creation of the user. And let's indicate the password here. We'll tell it to use the same for root and to receive the mail from root. And it uses SHA-512 as we saw in the GUI install. So now here are the various components. If changes need to be made, just navigate to each node and select change. So let's see what we've got going on here. Software. These are the different sections that we can modify. If the defaults look good, which for us they usually do, then just tab your way out through to the install. We've already seen the defaults from the prior installation, so we trust that the settings are safe. Now this will default to a footprint of 2.5 gigs and a default target, systemd target, which Red Hat also uses, systemd of GUI, which can be shifted after the fact. So we purposely use the larger footprint with the GUI so that we could change things after. So while this installs, let's just update our notes. So launches TUI interface. And let's just note that default options will launch the server in GUI mode with a roughly 2.5 GB footprint. So it's larger, unless you make the change that we did for the first server install. So that will copy 2.5 gigs. It's doing so via the image, the ISO image that was referenced, but we could have just as easily specified HTTP, which might have improved the I/O, but nonetheless, this gives us a text install. So this is being installed on the server. So that server is being populated. In fact, the server is here, and as we expect, it has the different consoles available, so you can navigate through them to see what the installer is doing, if there are any errors, so on and so forth. Or if your console redirects to whatever screen, whether it's a virtual screen or a physical or real screen, find your way over to it. But the instructions are there. The password isn't echoed, just the IP address and the script, the AS.SSH script to run post-connection. The 141 address, or the static address that was specified, will be applied when the system reboots. So subsequent connections will require that we connect with the new address. Let's pop back over to this node, and let's just take a note of that as well. So let's say that YAST installer derived an address via DHCP to carry out the installation. However, we indicated the usage of a static address, and this address will be applied post reboot. So subsequent connections, remote connections, will use the new address, and will be that'll be indicated on the console as well, to indicate, or to, so that we're aware, abreast of the fact that the address will change. But for now, it's 27, so it continues to use the same address, and that can be confirmed by sending some packets to both addresses. So let's say 75.141, and then how about 75.27? So one responds, the other does not. Let's see where we are with this install. Halfway mark. And it's moving at about the same pace as our other installs have. So far so good. It's straightforward. It's working as we expect. And this is how you do SSH. So just to quickly recap, we provisioned the instance on the ESXi server, tied it to an ISO image, booted that image, and then we indicated the usage of SSH by typing use SSH. In this case, use SSH equals 1, SSH password equals, and that allows us to connect. So let's just double check, make sure we provision the instance. Perhaps we'll say A1 use SSH equals 1 SSH. Let's say password is equal to whatever you want it to be. For us, that was install SUSE12. Indicate at boot prompt, and then connect, and make any other changes that are necessary, such as the usage of HTTP to obtain the SUSE RPMs for installation and so on. And then from the client, use SSH with the X option in the event that the server or the installer will return a GUI to you. If it doesn't, for one or more reasons, including but not limited to the inability to write to your local X console, it'll default to a TUI interface. So let's just note that TUI interface is the default. Let's say in the event of inability to write GUI to client. And that happens for a variety of reasons, including but not limited to, as we've just alluded to, the inability to write to the screen for permissions reasons. And that'll come about, for example, at the shell, this shell, we're logged in as root, but this gnome instance is owned by the user Linux CBT, or the non-privileged user. So the user root, although root, doesn't have default rights to write to the screen. So had we, for example, from this shell launched our SSH as the user Linux CBT who had rights, then the X session would have kicked back. But we'll see that momentarily. And yet another way to install SUSE is via VNC. Perhaps we'll look at that as well. Sometimes you just want to connect via VNC, have the full graphics, but not necessarily connect to the server's console through VMware, which sometimes can be slow, and so on. So that helps it out a bit to see the graphics that are available. Now this, we should probably elapse a little bit, just to buy ourselves some time. It's moving along nicely, but let's just elapse it a little bit. And this is just at the end of the various actions necessary to complete the installation. So we should be just about there. And by the way, if you lose your SSH connection during installation, the installation continues. You simply need to resume connectivity and rerun the yas.ssh script. That may happen. It's certainly a possibility, but it will not corrupt your installation. So in the event you're wondering what happens if the connection breaks, for example. So now this is ready to reboot. And we've lost our connection. Let's take a look at the console. There's the console. This will bring us back to a point where we can finish the installation remotely using SSH. And that may simply mean just SSHing into the system. But let's see where we are. So this is going to come up with a GUI. That's the default target, equivalent to run level 5. And there's the GUI. So the install is over. And let's see if we can connect. Well, let's first take a look at the IP settings here. So give us a desktop using SVGA. And there you see we're at 141. Let's send some packets to the client as well as to the gateway. That looks good. So this is up and running. In terms of connectivity, let's do a sudo IP tables list. So this is 141. Let's grep SSH. So accept TCP anywhere to SSH. So we should be able to connect. So let's see from this perspective. And this actually, we launched the YAS connection from the wrong server. Actually, we launched it from the remote server, build 1, not from our local client. Another reason why the X session failed, or the reason why the X session failed. Let's SSH into 75.141. Let's see what's happening here. So there's a node. Its host name is not written. That needs to be updated, of course, using YAS. So we can do a sudo YAS and make that change. And we'll also want to take note of what we just discovered, because one of the things with SSH, if you don't read the prompt every time, and it's something we still neglect to do at times, then you can run the risk of being on the wrong node, running something from the wrong node. So here's our etc hosts entry for the arbitrary name that's used. That'll be updated once we update the host name. Let's cancel and go back. But that's definitely an issue, something to be concerned about. Now let's modify this host name here. This is going to be CVT SUSE 2. That looks good. In terms of the name server, for now we're just going with 101. Once we look at DNS, we'll point the instances exclusively to the SUSE instances. Search domain optional. And let this write. And we'll just double check the host setting again. Let's go back to this window. So network services, host names. And let's see, there's our SUSE2, short and long. That looks good. And now we're looking good. Let's quit. Now in terms of the host name itself, if we drop, let's say we drop and reconnect. There's a new host name. That looks good. And in terms of the installation, as we've mentioned, let's just include that. Note, in our case, TUI interface defaulted because we SSH'd to the installer or to YAST. Installer via a third-party host. So that's the problem. That's the reason why we're not able to get the X11 session back to our system. Otherwise, it would have come up with a GUI. And to clarify that point, we just simply need to relaunch the installation. So just as an example, we don't have to commit it, by the way. So let's say we sudo init 0. That'll shut this. And let's just make sure that the DVD or ISO image is set to connect when the system comes back up. So let's bring this in. Let's take a look at the settings associated with SUSE2. So we'll take a look at edit settings, CD DVD drive, connected power on. So it should come up. Now let's fire this back up. So this is coming up with the hard drive only. Let's shut it down again. It's defaulting to the hard drive, actually. And there we are again. Just had to shift the boot order. So, hard drive or installation. But we want to make sure we put the use SSH equals 1. Install SUSE12. Optionally host IP. We're not going to continue in the installation. So long as you don't repartition or overwrite the existing file system with new RPMs and so on, then you can always reboot the system to the previous installation. So we won't run the risk of overwriting the previous configuration or overwriting the contents of the disk. That's not going to be a problem. It's just to illustrate the point that the GUI would come up or be invoked in the event that X is able to write accordingly. So 7527 again, that's the default address served by the DHCP server to this particular client. So you connect into 27. Let's pop back over. And then let's say from this shell, we SSH using the X option. Uppercase X, that is. Everything matters here. Actually, we want to connect as root to that node. First time from this node, so we accept the key. Then once on, we launch YAST. Let's double check that. Install SUSE12. And now we run YAST SSH. And then this brings the GUI up, at which point we can continue as if we were connected to the console. So that's the difference. And this uses SSH in conjunction with X11, as we've seen across prior releases of SUSE, whereas VNC uses the VNC protocol. So although they look alike, they're using different protocols to effect or commit the installation. So let's skip this. We won't commit the changes, actually. We just want to make progress towards the section where we'd normally make the changes. So this would be normally etc, gmt, next, first user, and so on. So you get the point. Let's click on next here. And there you see the settings. So now what we're going to do is abort, as we don't want to commit these changes, and ensure that the system's able to reboot. So let's go back over to our setup here. There's obviously an error thrown to the screen. And when we issue the Control-Delete, we should ensure that the system does not boot from the ISO image. So let's exit and reboot the system. So that's still the ISO image, but it defaults to booting from the hard drive. So the idea here is to send Control-Delete into the window and enter the BIOS. Now that usually happens very quickly. So Control-Delete, but that pops us back. So it tells us here, detected the Control-Delete. To send Control-Delete, type Control-Insert instead. That's the that's the workaround, so it doesn't trap it. Otherwise, if you boot from the hard disk, it will just come up as it was priorly configured to do so. And to ensure the ISO image doesn't boot, a quick workaround is just to disable the connected drive. So for example, for SUSE2, edit the settings, and for the CD drive, just tell it not to connect it, power on. And that means the next time it reboots, it won't be connected, at least not to this node, until you can get to the BIOS. So the BIOS setting will still read that it should try to boot from CD-ROM, but the drive won't be connected, so it won't be able to, so it'll default to the next item on the list. Let's see where we are here. And it says locked CD-ROM. And that's because it used it initially to boot. Let's go ahead and see if we can get back to the console. Sometimes we lose the console access. And while that tries to bring the console, let's see if we can ping it. So ping 192.168.75.141. So it's up. It's there. Let's see if we can SSH into it. We should have an instance here. There it is. We're just not getting the console. As we've mentioned across various releases of Linux CBT, sometimes the VMware ESXi console is becomes non-responsive. So now it's responsive. So it's available. Let's save some resources back off of the console so it doesn't have to draw that information. So our TUI didn't come up because we were SSH'd into a third-party system, into our common system that we call Linux CBT Build 1, which runs Ubuntu, and then from there we connected to the SUSE instance. So we were just one hop too far away, or one hop too many away, to reroute the X11 session back, but we saw the X11 session, so that works. And again, differentiate SSH in conjunction with X11 from VNC. VNC is a different protocol. They both look alike. They draw the screens. They redirect the console information, but they're different protocols. So now we have our second node up. Let's move on.